Good news, we're back with another episode of Armchair Architects, the Azure Enablement series that's an ongoing conversation with Uli and Eric, two of the smartest architects I know. This episode, we're going to talk about the relationship between cost and architecture. So join us. Hey folks, welcome to another season of Armchair Architects. We had such great feedback and a whole bunch of questions from the people watching that we thought we'd do a season 2. So I'd like to welcome back our architects, Uli and Eric. Well, welcome back, Uli and Eric. It's good to see you.
Great to be back.
Great to see you, David, man.
So I was really hoping we could answer some of the questions that piled up after season 1. The first topic that I think is super interesting to address is people are asking about sort of the intersection between architecture and cost, right? And I get the sense that this is a little more subtle than people think. It's not just like more architecture, more money, right? Can we talk about some of the factors that go into how cost and architecture interact?
Yeah, absolutely. I think maybe I'll begin by telling a story, and I'm sure many of our experienced architects out there have been part of a story like this one, in which you spend months trying to craft this elegant architecture, implementing multiple patterns that we talked about in season 1, and then it goes into production, and then the finance manager gets the first bill in the email that says how much it costs to actually run this system. And that's when you realize, oh, I missed a crucial step. In the quest to design a fantastic, beautiful architecture, I didn't take into account the workloads among all the constituent components of that architecture and how much they would actually cost in reality given production workloads.
What makes it more costly, though? I mean, why can't it be elegant and smaller? Like what typically happens as part of the architectural design process where you find yourself accumulating cost?
I'm curious to see what Uli thinks here, but in my own experiences, in terms of developing and selecting the perfect component that's going to be performant, scalable, manageable, there are different tiers of services that you can select, even within our own cloud stack. And in the quest for simplicity, but also performance, you might immediately select the exact right one for the job. But at the same time, that might have a different cost component from a service perspective than a next best alternative, in which case you might have to refactor your architecture to select and accommodate for that alternative.
Yeah, so the way I think about this, David, is that the cloud has opened new opportunities to really think about costs. When you're in a CapEx world, you make the investment once and then people just don't think about it. It's the infrastructure is available, it's statically priced. In most cases, doesn't have to be, but in generally it is. Therefore, you always go for the highest level of infrastructure because it's a one-time investment. When you go into the cloud, all of a sudden you have OpEx, which means operational costs. Every time you use a capability in the cloud, it does cost you for that specific period of time, which means now you need to think and you have the opportunity to choose, which on the CapEx side often doesn't happen. And now you need to start to say, how do I use modularity? So we talked about this as workloads in the previous session. How do you use modularity to say, for this module, I only need 4 nines or 3 nines or 2 nines or whatever the availability is, which means I can go with cheaper components in the cloud. Like Eric pointed out, there's options. Services have different grades with respect to availability, scalability, and those kind of things. So you might be able to choose a cheaper component for a workload that only needs 2 nines, let's say. And then you say, I'm going to a higher level because I now need 4 nines for this workload. And therefore you use a, let's say, business continuity enabled SQL Server service instead of the standard SQL Server that has high availability but might not have BCDR. Again, I'm just making this up right now. But the opportunity is for you to choose and to start to think about how do I really map the requirements per workload onto my infrastructure. The second thing I would add is you also have the opportunity to look at elasticity. Again, people still a lot of times over provision in the cloud. They don't need to do that anymore because you can grow and shrink your workloads based upon demand. You can also do things like where a lot of enterprise customers specifically go and utilize environments, so dev, test, pre-production, user acceptance, and those kind of things. You don't really need to do that anymore because you don't have to have standing environments that effectively are just humming along until they are needed. What you can do is to bring those up on demand, and when a developer needs an environment, they get one. But once it's not needed anymore, it gets torn down so that no costs are accrued. And those are some of the levers. So think about the services and workload alignment, elasticity in terms of what do you need when, and then also think about environments as a way for you to think through, yes, you need those environments, but you don't need them 24/7. So you need them on demand. So there's a lot of ways you can effectively utilize the cloud to work on your cost models that were unattractive or not as interesting in a CapEx model.
And I totally understand that last part because, you know, if nobody's going to be in on the weekend, having a bunch of environments humming along in our data center does you no good, but costs more. When we talk about pricing tiers and we talk about getting bigger things or more expensive things, I think a lot about that as being like scaling up versus scaling out. Do you think that the cloud provides the opportunity to do more scale out infrastructures or more globally distributed infrastructures? And that's one of the things that people are encountering, like, oh, cool, now I can actually really do this in a globally distributed way without having to put a data center there that I don't own or rent some space in the data center?
I think definitely that's the case. The benefit of the cloud is, like you said, that scale out, that regional availability, that geographic availability that are options to you now, whereas there would have been a CapEx expenditure profile with that sort of scale before. But I think that there's a couple of things in transitioning into that mindset, which is you need to understand what your potential operating budget will be, and any restrictions around that. So again, designing for geo-redundancy and regional availability is fantastic from a functionality standpoint. But we have to know how much this car is going to cost, if that makes lots of sense, over time to maintain. And then as you design, you have to work backwards from there to say, well, hey, if you want this level, it's almost like a negotiation. If you want this level of performance in terms of regional availability and horizontal scale, that means it's going to cost this much more per month. And while we might not need that right now, it's something that we can turn on in the future. And this is what the forecasted expenditure for this particular architecture will be.
Yeah, and again, David, I look at this as aspects of elasticity, because you have horizontal elasticity, well, let's say within a region or within a cluster. And then you have a network of resources where, depending on your scenario, you might want to leverage that network of resources. So Azure has right now 70 something regions across the globe. Then you're getting edge zones from partners like AT&T and other partners out there. So you can really think about, where do I place my applications and when do I place them? The time horizon is something that a lot of people don't play with. And I think cloud is a perfect environment for you to think through. Workloads are not stable 24/7. They generally fluctuate across the day, across the week, across the month, whatever the workload type is. And I think elasticity in terms of moving resources along and using resources dynamically is really a perfect play to think about costs to get to this ultimate number that Eric is pointing out.
So I like talking about elasticity. The place that I get into a little trouble, and I'm curious how architects handle this, is there's some notion in the back of our heads that elasticity is instantaneous. Like there's some notion that says, okay, I want to expand out, no problem, we're in the cloud, I push the button, I can get 100 more, 1,000 more, that sort of stuff. But I don't think, as far as I know, I mean, I know that it takes time, right? It takes time to spin up more of this, or to warm that cache, or to whatever. How do architects think about that temporal component of, okay, we already know we can expand, and I've got that in my toolkit. How do they think about not the temporal over like time of the day, but temporal like, hey, it's going to take some time actually to scale out. How do you build an architecture that takes that into account?
Well, my thought process here is like, it's not an unreasonable expectation. The expectation is that cloud computing is infinite scale, infinite capacity, and all I need to do is turn one giant knob and everything just figures it out, and the cloud figures it out. As we know, reality is some steps backwards from that, in which you have to understand the configuration planes and control planes associated with each component. And then as an architect, in my mind, you have to actually look at what are those temporal milestones that I need to hit in terms of scalability. If I'm in a seasonal business in which my orders might spike around the Super Bowl, I need to have a stepwise progression and a practice plan of scaling up in time to meet the demand. And today, where we are, the reality is, from a component and a service standpoint, you may actually have to go in and flip some switches and modify some dials to do that. So I think part and parcel of it is the architectural design, and then these temporal milestones around how do I change or modify the properties associated with this architecture so that it will scale and I can leverage the power of the cloud most efficiently from a budget standpoint.
I would add to this, and that's something that a lot of people don't take into account. When you scale one component, let's say you scale the compute component, you put more pressure on to the persistent data tier, let's say a database. You need to think about, does the database need to scale as well when I scale the compute tier? Or if you scale the solution all up, all of a sudden your monitoring capabilities need to scale as well. So that's one of the reasons why internally at Microsoft, we generally think of scale units. A scale unit is effectively all the resources you need, management, application, compute, storage, etc., to satisfy the demand for a specific capacity. So you don't plan for ultimate capacity anymore, like you used to do on-prem.
Right.
You now plan for slices of capacity that can be scaled out. And that's what's called a scale unit. So let's say if you're in the messaging business, mail, you would say for 5,000 users with this many messages, for this much storage, I need this many Exchange servers, this many monitoring capabilities or whatever it is. And then you scale it out for every 5,000 users. And you could do this with 5,000 transactions, whatever the measure is that makes sense for your application. And then good news is you can rely on the dynamic scaling capabilities that are built into the cloud services.
Yeah.
You just have to trigger the necessary scaling, because a compute tier scalability is not aligned with the database scalability. So you might have to give hints to the layers that says, hey, I'm scaling the compute tier, monitoring tier, scale up to, or scale out, sorry. And so that's where I think, not complexity, but you have to orchestrate scalability along the lines of what we call a scale unit.
Yeah, David, if I can hone in on what Uli just said, the scale unit concept, I think, allows for symmetric scaling of the solution, so that the last place you want to be is trying to figure out on the fly the weekend before the demand spike happens, or hopefully less frequently would be you in the middle of the demand spike trying to figure out, well, how many, for this particular service, how do I turn the dial up? And if I do that, is that going to overwhelm my database tier or my storage tier or my network tier? The scale unit concept is basically like the blueprint that says, if you need to scale to meet this particular demand, go turn all these knobs and these dials across all of your cloud services. That is super important as an operational paradigm.
Well, you were just about to get into the question that I was going to ask, and you may have just answered it, the two of you, because I was thinking there's some number of people who are watching this who are like, you guys are awesome. You know, you're assuming like omniscience, that I already know what I have to scale to. I already know that the Super Bowl is going to happen on that day. But there's some number of people out there who are like, I have these flash sales, or some famous person mentions my product on social media, and all of a sudden I'm off to the races here. That I could not have predicted. And so I was going to ask, what can you do from an architectural perspective to handle unexpected scaling requests? Are there architectures that are more or less conducive to that? I guess is the question.
So we talked about this last time. So this is a combination of elastic scaling.
Right.
But as you pointed out, David, it does take time. There is no zero latency and just magic happens. It goes very fast, so it's not that it's going to take a lot, but you couple elastic scaling with throttling. Remember that we had that conversation where you effectively protect your service from getting overwhelmed. So you might shed some customers along the way, but at the end of the day, it's better to be predictable and shedding some customers along the way than trying to scale and take everything in and then ultimately failing completely. So for me, elastic scaling coupled with a scale unit concept allows you to scale up and down against a given capacity. and then you protect your service with throttling, and then therefore you can handle these crazy spikes that happen.
I'll also reverse plug our session from last season, in which we talk about resiliency, which is if my components, my user experience components, have a network failure because of throttling or an overwhelming or unpredicted spike in demand, which, let's face it, that does happen. The user experience and the architecture associated with that user experience has to be designed in such a way in which it handles those conditions gracefully, or as graceful as possible, until we can actually take action in the scale unit methodology, as we said.
And what do you do in cases where we're talking about geo-redundancy? So let's assume enough demand comes in to knock over an entire region or something like that. And I've been clever, I've deployed to 4 regions, everything is cool. In theory, my other regions should be able to take those on, but maybe they can, maybe they can't. And then there's also sort of the speed of light problem. So what can architects do to not be naive about geo-redundancy and how that goes?
So I've got a really simple answer, which is not sarcastic in any way, but to me, it's what's that old saying? Chance favors the prepared mind, right? So in my estimation, think about it before it happens. So for example, if a region falls off the map or the data center goes, then where do you redirect all of that data center's traffic? Well, it's got to be to the next, hopefully physically the next available zone. And so that should be an operating procedure in which you go, hey, this has fallen off the mat. Let me change my network infrastructure so that all requests go from this region 1 to region 2.
So let's clarify the topics, because you, Eric, mixed 2 concepts. If a region falls off the map, you go to another region. And if a zone falls off the map, you fall into another zone, because a zone is part of a region.
Yep.
Regions are effectively. But David, from an architecture perspective, there are 2 things you need to do. One, ideally you are in an active-active configuration, which means that the services are hot on both sides, the data is available on both sides, and you effectively are replicating the state back and forth between, let's say, the 4 zones, 4 regions. Now I'm being not proper. So you effectively replicate the data between the 4 regions. Maybe you have failover pairs, whatever you like. But you're doing an active-active management of the resources. The second level then is using things like Azure Traffic Management or Azure Front Door as capability to effectively manage the load balancing that Eric also pointed at. And so you effectively are using traffic shaping and traffic management to make sure that the traffic balances between the regions that you use, and you use active-active paradigms ideally, because that makes it so that there is no failover. If you lose a region, the other regions just take over where the one region failed, and that is effectively obviously smoother. It's also more expensive, except if you are having a global or a geographically distributed anyway business, then you can use it to load balance from a latency perspective, and also provide you with high availability across multiple regions.
So you just did exactly what I was hoping you were going to do, is I wanted to take this right back to our original topic, which is cost, right? So what are you going to say as an architect to somebody who says, that sounds awesome, Uli, but that's pretty darn expensive, isn't it? Can you architect your way out of that expense, or you say, sorry, cost of business? What's the answer to questions like that from an architect?
So unfortunately, the answer to the question is, it depends.
Uh-huh.
If a region failure and let's say you're doing a active passive deployment, and the startup time to get the site up on the other side, if that's too long and your cost of business is effectively impacted, then an active-active deployment makes sense. If it is not too long and you say my SLA to provide these services, let's say 4 hours, then don't go active-active, go active-passive. But if you are having a requirement to be available even if a region fails, which is also a question, doesn't have to be automatically, if a region fails at Microsoft, I have 3 weeks to get this back up. Hey, don't go even active-passive. Just make sure that you copy the data on a regular basis over to another site so that it's available for you to reconstruct the system. So for me, there is no black and white answer. It really depends on the business case and your flexibility with respect to bringing the solution back up. If it's instantaneous because you're really using money, let's say you are a retailer on Black Friday, you don't want to do active passive. You want to do active because you don't want to miss orders. But if it's a Super Bowl and you're a pizza provider, but if it's something which can take 3 weeks, don't invest the money. For me, it's a balance that an architect needs to start thinking about cost as an active ingredient in planning and in designing his or her solutions. And I think that's the number one message I would take home from this conversation, is cost is something that is not for the other people. It's not for everybody.
Well, I'm also thinking that what is the cost of going down on Black Friday? You know, like that's probably a significant cost too. And I'm also thinking like that we have dug into cost here, but as I'm thinking about this, I'm thinking like these are really smart answers. And like, how do you become such a smart architect? And I'm just wondering, like, as segues go, like I know that one of the things that people were asking us was, how do I become an architect? How do I start to think about these things? And I'm wondering if you'll join me in another episode and we can actually talk about how do you get to the place where you can have your own answers like this as well. Would you be up for it?
Absolutely, anytime.
Cool. Well, then I want to thank you all for watching. Thank you, Uli and Eric. And we'll look forward to seeing you on another episode of Armchair Architects.